Good evening everyone. In this section, we are going to solve some IBM sample coding questions. So first we'll read the question and try to come up with the logic. After that, we will solve the question. Here is your first question, Sieve of Eratosthenes. Here I have a number n. I need to calculate the prime numbers up to n using Sieve of Eratosthenes. So normally we can solve the coding program to find the prime numbers within a range. Here using the algorithm Sieve of Eratosthenes, we need to calculate the prime numbers up to the range. And here the expected time complexity is big O of n log n and space complexity is big O of n. So here we can see the input and output. So 10 until 10 I need to print all the prime numbers. The numbers are 2, 3, 5, 7. So prime numbers less than or equal to 10 or 2, 3, 5 and 7, hence I am printing it so. Now we'll see how we can solve this question. So basically how I'll be running a prime number code. So I'll check till the number whether the number of factors for each number is 2 or not. So if it is having only 2 factors, that is whether it is divisible by itself and by 1 alone, then I can say that particular number is prime number. Now the Sieve of Eratosthenes, this is an ancient algorithm for finding all the prime numbers up to the given limit. Also, it is an efficient method compared to other algorithms for finding the prime numbers. So especially when we are dealing with small numbers. So here what I'll do is, first I'll create a Boolean array of size n plus 1. So here this is a sample input and output, right? So what I'll do is, first I'll create an array of size n plus 1. Let me take the size as n. So I'll create an array of size n plus 1. And why? Because here this n is the upper limit up to which we want to find the prime numbers. And what I'll do is, I'll take this as a Boolean array and initially I'll set all the values as true. So initially all the elements are set to true, assuming that all the numbers are prime. So now I'll start with the first prime number. So what is the first prime number? 2, right? So I'll mark all the multiplies of 2 as false in the Boolean array as they are not prime. Now if we take the multiplies of 2, see we have 4, we have 8, 16, so all these things, 12. So all these things are the multiplies of 2, right? So they are not prime number. So I'll start with the first prime number and I'll mark all the multiplies of 2 as false in the Boolean array as they are not prime. Now again I'll find the next unmarked number. So next unmarked number is 3 because 2 is already marked. Now it is 3. Again 3 is a prime number. So again I'll mark all the multiplies of 3 as false in the Boolean array. So here also the same thing, 3, 6, 9, 12. So all these things will come under this category, right? So all these numbers are not going to be the prime number. So I'll mark all its multiplies as false. So this is the process. I'll repeat the process for the next unmarked numbers until square of the current number exceeds n. So for each prime number, what I am finding out, okay, for each prime number found, I'll mark all its multiplies as false. So after the completion of the algorithm, all the numbers that are still marked as true will be prime numbers, right? So actually the idea behind the Sieve of Eratosthenes is that any composite number can be divided by a prime number less than or equal to its square root. I repeat, any composite number, that is non-prime numbers, can be divided by a prime number which is less than or equal to its square root. That is the reason I am finding the prime number and I am making all the multiplies of prime number as false since they doesn't fall under the category of prime numbers. So By marking the multiples of prime numbers, we can eliminate all the composite numbers from the consideration, leaving only prime numbers behind. So, which we have the true value alone, we can print finally. So, the algorithm has a time complexity of big of n log n, which is quite efficient for finding prime numbers up to a given limit, because it eliminates the need for checking divisibility of all numbers up to n, right? So, first case we are not checking till n, we are checking till the square root of n, that too we are multiplying, we are deleting the multiplies of that particular number, right? So this will reduce the number of operations which is required, right? So this is how I am doing. Now we will implement the code. So first, basically I'll be start with a header file. So let me start with a header file here. Hash include bits std c++.h using namespace std in order to get the C++ and like C and C out functions. And later let me start with the main function here. So inside the main function I need to get the value of n. So I'll declare a variable n and I'll get the value of n from the user. Here let me call the function and I'll give the name of the function as Sieve of Eratosthenes of, where I'll be passing the value n. So this is a function which I am gonna use here. Now I need to define the function. So in order to define the function, let me take the same function name and the data type, return type void. So the same function Sieve of Eratosthenes, here I need to declare the variable, the parameter differs, right? Yeah. So what is my first process? Let me take a boolean array. So here I am taking a boolean array named prime of size n plus 1. Right, yeah. So I have declared a boolean array. After that, here I'll make use of memset. So the reason is initially all the elements are set to true. After that I'll find the next marked unmarked number, right? So using this particular function. So let me make use of memset, where I'll be passing my array, then the values, and what about the size of array. So all the three things I'll be passing inside this particular memset. Now I can run the loop for int. Let me take a variable p is equal to the first prime number 2 and I'll run till the square root of that value. So p into p less than or equal to n and p plus plus. Now inside this I can check the condition whether prime of p is equal to true. So if it is equal to true, again I'll run a loop for int I is equal to square root of that number, because I need to check whether it is equal to the square root of that number or not. So I plus is equal to t. Here I'll make all these numbers as false because I am taking the multiplies of those numbers using this particular for loop. So once this two process is done, right, now I can just print what and all having the true value, I can return that. For that I am just taking another loop for p is equal to 2, where p value is less than or equal to n and p plus plus. Inside this I'll check the condition whether if of prime of p. So if of prime of p, if it is true, that is if the value is which is returning here, if it is true, I'll just print the p value that represents the prime number and I'll leave a space before printing the next number. Now I am closing this function, right? So this is what I'll do. So here let me explain the code again. Yeah, so what I am doing here it is, first we should find all the prime numbers up to a given integer n. Right. Now I am including the header file bit slash stdc++.h, which includes all the standard C++ libraries. And this particular function takes an integer n as an input, which represents the upper limit for finding the prime numbers. Inside the function, I am taking a boolean array of size n+1, which is declared, and this array will be used to mark the numbers as prime or not. Now the memset function is used to initialize all the elements of the prime array to true, indicating that all the numbers are initially assumed to be a prime number. For that purpose we are doing it. Prime, true, size of prime. Yeah. Now the inner loop starts from I is equal to inside the loop. Here I will be checking the condition whether the prime is equal to true. If so, if P is marked as prime in the prime array, if P is indeed a prime number, the inner loop is executed. So what I am doing inside this inner loop, I am running from I is equal to P into P, that continues until I is less than or equal to n. So it iterates through all the multiplies of P and marks them as not prime by setting their corresponding indices in the prime array to false. And after the completion of the loop, all the numbers that are marked as true in the prime array are prime numbers. So for that I am checking here and I'll print those numbers. So the final loop P is equal to 2, P less than or equal to n. This is used to print all the prime numbers found. So it checks if the value of prime of I is true and it will print the corresponding value of P. In the main function, the code takes the input for n and I am calling the function. So altogether, this works by iteratively marking the multiplies of prime numbers as not prime numbers. So it starts with the smallest prime number 2 and iteratively marked its move to the next unmarked number and repeats the process until all the numbers up to n are processed. Finally, the algorithm collects all the remaining unmarked numbers, which are the prime numbers up to n. So this is Sieve of Eratosthenes algorithm. Now let me run the code and check is there any error or not. Yeah, so I got it. Now let me give the range. Yeah, so all the prime numbers till 10 is getting printed. It is 2, 3, 5 and 7. Yes. Yeah, so this is our next question. Write a program to implement a stack using array. So if there is no value, I can print the stack as empty, and if top is greater than the given n value, print stack overflow. So we all know about stack. Stack is a linear data structure that follows a last in first out principle. So it can be visualized as a stack of items where the last item added is the first one to be removed. Right? For example, a stack of plates. So when you add a new plate, you place it on the top, right? And when you want to remove a plate, you take from the one from the top. So now we need to implement the stack using array. So it is used to store the elements of the stack, and we can take a global array with a size of 100. So you can even modify it as well. So while doing the code, yeah, here itself we can do. Now let me start with the same header file, hash include IO string using namespace std. Yeah. Now let me take an array and I will name it as stack itself, and the size is 100, and I'll take some variables. Top is -1, so initially the value of top is equal to -1 only. Now inside the main function, I'll declare some variables int I and value. So I'll get the number of elements, and after that I'll run the loop for I is equal to 0, I less than n, I plus plus, in order to get all the values. So I'll get the values here. Right. So after getting all the values, I'll just push it into stack. For that I'll call the push function. So once I have pushed it into the stack, I'll call the display function to print the elements which is present inside the stack. So now we need to define two functions over here. One is a push function and other one is the display function. So push function void push of, here the parameter I'll take value and I'll be checking the condition whether the top is greater than or equal to n minus 1. See why? Because I have initialized the value of top as minus 1. So when the stack is empty, the value of top will be minus 1. Now I'll check the condition whether the top is greater than or equal to n minus 1. So if it's so, I can't add any other elements. So it is already filled, right? So now I'll be printing stack overflow, because already the stack is completely filled and I'm not supposed to add any new elements over there. So if I'm trying to do it, so it will print stack overflow. If not, I need to increment the top value each time, where this top represents a size. So stack of top is equal to, I'll insert that value, right? So this is how I'll perform the push operation. Similarly, if I want to display all the elements in the stack, I'll call the display function, where I'll be checking the condition whether the value of top is equal to greater than or equal to 0. If the value of top is greater than or equal to 0 means, what I can do is I can print all the elements. So here you can see I'm just printing stack elements are, and I'll print the elements as it is. So stack elements are, right? And in the next line I'll print all the elements. So in order to print all the elements, I need to run the loop. For I is equal to from the top I'll run, right? So for I is equal to top, I greater than or equal to 0 and I minus minus, inverse for loop. So here I'll print the values. So in stack of I, so each value will get printed. After printing each value, I'm supposed to leave a space. And once this is done, I go to the next line. So if this condition is satisfied, I'll do all the process. So if the condition is satisfied, I'll do all the process. What if the condition is not satisfied? If the condition is not satisfied, I'll print stack as empty, because stack is not having even a single element. So that is the reason the value of top was not greater than or equal to 0, since we have initialized the value of top as minus 1. Now let me run the code and check. So here first I need to give the size and the elements. Oh, I have given a space already, fine. So the stack elements are 5, 4, 3, 2, 1. So as I told you already, this actually follows last in first out. So the last inserted element is 5. That is the reason it is printing first, right? So here the global variables are declared. Stack means an integer array to hold the stack elements. Integer variable to store the size of the stack is n. And top is an integer variable that represents the index of the top element in the stack, which is initialized to -1 to indicate empty stack. And the pusher function is defined to add the elements to the stack. So if the value top variable is greater than or equal to n-1, it means the stack is full and the function displays stack overflow. Otherwise, it increments the top and assigns a given value to the stack array at the updated top index. And the display function is defined to print the elements of the stack in the reverse order. So if the top is greater than or equal to 0, the function it prints like stack elements are, and I will use a for loop to iterate from the top to 0, printing the stack elements in the reverse order. If the top value is less than 0, it means the stack is empty and the function displays stack is empty, right? So this is how I will be printing the stack elements. Thank you.